Hi, my name is Laura Szymanski, a teacher at Edina High School. Today I am going to give you some of the key concepts that we talked about in Lesson 10 of the Eureka Pilot, Building Logarithmic Tables. The opening exercise had us explore a pattern, and so I'm only going to focus on the right column. What power of 10 is 1,000? And we get 3. One thing that this makes us think about is log base 10 of 1,000. I could rewrite as 10 cubed, and that's also 3. So we're looking at patterns as we go. Power of 10 is 100. That's 2. Again, I could rewrite it as log base 10 of 10 squared if I wanted to, because 100 is 10 squared. This one is 1. And again, technically there's an exponent of 1. Log base 10 of 1 is 0 because 10 to the 0 power is 1. I could, in theory, rewrite it. 1 is 10 to the 0 power, and we got 0. Log of 1 over 10, the one thing I want you to think about, that is the same as log of 0.1. We go back and forth between those. And again, the what power of 10 is 1/10. It has to be negative because that's what flips it, and it's just a negative 1. Again, I could rewrite this as log of 10. 1/10 is 10 to the negative 1, so we could write that. And finally, log base 10 of 10 to the negative 2 is this one. And so I see that that's negative 2 as well. All of this, if we look at the pattern, we can see that if we rewrite it in exponential, what we're taking the log of, the exponent is the answer. Now again, keep in mind this is the case only if the base and this number are the same. So if k is an integer, then log base 10 of 10 to the k is k. It's the exponent. Okay, so then I'm going to skip ahead to these log tables. It says you'll use your calculator to complete the following things. These are what we call log tables. And again, this lesson was called Building Logarithmic Tables. So really what you would be doing in this situation is you'd just be typing in the log of 1 to your calculator. Remember, if there is no base, that is a base 1. I'm only going to fill in the first entire table. So log of 1 is 0. Log of 2 is 0.3010. Log of 3 is 0.4771. Log of 4 is 0.6021. Log of 5 is 0.6990. Log of 6 is 0.7782. Log of 7 is 0.8451. And log of 8 is 0.9031. Log of 9 is 0.9542. Now, when I start to build, so this is table 1, when I start to build table 2, I type in log of 10 and I get 1.0. Log of 20 was 1.3010. Log of 30 was 1.4771. Log of 40 was 1.6021. Log of 50 was 1.6990. I'm going to stop there because really the purpose of looking at this is just to compare table 1 to table 2 and see what pattern we recognize. And what I see is that in my second column, to get from 0 to 1, I added 1. To get from 0.3 to 1.3, I added 1. So I can see that the pattern is that it's going up by 1 every time. So then I want to compare what's happening with my x's. Well, to get from 1 to 10, I did 10 times x, right? To get from 2 to 20, I took 2 times the original x. So this table represents 10 times x in the first table, and I'm recognizing that my logs are going up by 1. If now I build my third table, and I type in log of 100, I actually get 2.000. Log of 200, I get 2.3010. Log of 300, I get 2.4771. Log of 400, 2.6021. Log of 500, 2.6990. So in this case, I can just see that if I compare table 1 again to table 3, okay, so I'm jumping over the middle one, I can see that my logs, I'm adding 2 to the original log. And so once again, if I compare log of 1 to log of 100, I actually see that I'm doing 100 times x, and if I do 2 to 200, so I see that's consistent throughout. That's not a coincidence. I also want to keep in mind that I can rewrite 100x as 10 squared times x, like we talked about in the opening activity. Okay? So none of this is a coincidence. And so this was supposed to lead us to see this pattern and to be able to come up with some conjectures. And what we saw is that when we tried to find the log of 10x, it was 1 plus the log of x. So this is how we would write out what we just found in logs. And when we had log of 100x, or that's the same as log of 10 squared times x, we said it's going to be 2 plus the log of x. Now if we just look at this log of 10 squared and ignore the times x, our opening activity said if we have log base 10 of 10 squared, it is going to equal 2. So it's not a coincidence that that happened. In this case, it's like 10 to the first. So if we just look at the log base 10 of 10 to the first, that's where this one comes from. Now, one of the activities that we skipped on the previous page, the star example, gave us a better reason as to why this plus log of x happens at the end. But tomorrow's lesson will actually do a really good job of helping you see that better. So that's why I skipped over that today. If we use this, you could hopefully make a conjecture about what happens if it's log of 1000x, and it would always start with 3 plus, so that would be 3 plus log of x. Ultimately, in number 10, we are looking to write it for any positive integer k, because again, we have only been looking at positives so far. And so for this one, we can write the log of 10 to the k times x will equal that exponent, because log of 10 to the k is k, plus the log of x. Now again, right now we're saying for any positive integer k. Now, this next part is pretty repetitive of what we just did, so I'm only going to type right in the first 3 boxes. You can continue to fill them in if you want, but we went through and we filled in these log tables. The difference is now instead of multiplying by 100, we did 1 to 110, or by 10, we actually took x and divided by 10. Now another way we can write that is 0.1x like we just did. Or, if we're dealing with exponents, that's 10 to the negative 1x. Okay, so all 3 of those are true. That's how I got from the first table to the second table in this example. And in this case, when I typed in log of 0.1, I ended up getting a negative 1. When I typed in log of 0.2, I got negative 0.6990. Negative 3 is negative 0.5229. Now sometimes this pattern is a little bit harder to see, but if I really just compare the 0 to a negative 1, my conjecture is that I'm going to subtract 1. So what I did is or add a negative 1. I then took 0.3010, did minus 1, and I did in fact get negative 0.6990. When I fill in table 3, I did log of 0.01, which is me taking the original x over here and actually dividing by 100, which is the same as 0.01 times x, which is the same as 10 to the negative 2 times x. Okay, so it's important we understand that it can be written all 3 ways, and when I did log of 0.01 I get negative 2. Log of 0.02 is negative 1.6990. Log of 0.3 is negative 1.5229. So again, as we built these tables, the pattern might have been a little harder to see, but if I compare 0 to negative 2, my guess is that I add a negative 2 or subtracted 2. So then I just tested 0.301 minus 2, and I did in fact get negative 1.6990. So these tables allowed us to look for patterns again, and once again this time we found that the log of x over 10, so table 2, which I'm going to write it all 3 ways, is the same as log of 0.1x, which is the same as log of 10 to the negative 1 times x. Every single one of those times we took the negative 1 and we added the log of x. And again, if we think about this part, 10 to the log base 10 of 10 to the negative 1, we do get negative 1. So what that shows us is it does work with negative exponents as well. I will show the second table as well. Log of x, or third table, log of x over 100, same as log of 0.01x. If I write that in exponential form, it's log of 10 to the negative 2 times x, So once again, looking at this, I should get a negative 2 plus the log of x, which is what we just said. Once again, they had us look at it for log of x over 1,000, but again, because I could rewrite this as log of 10 to the negative 3 times x, it would just be the same as negative 3 plus log of x. So we broke it down looking at positives and negatives separately, but our conclusion is that it doesn't matter. If I have the log base 10 of 10 to the k times x, it is in fact equal to k plus log of x, just like we said on the few pages ago, but for any integer k. So the change is that we aren't saying positive. Okay, so using this key concept, so this is what we spent the day building. We can use that to solve a variety of logs by hand. So we're going to finish up with 2 quick examples. The way these problems would be written is it would say use log tables to calculate to 4 decimal places. So really we could do this without a calculator as long as we can get it into this form. So for example, if I give you log of 30,000, okay, I need to get it in this form. Well, that's actually like changing it to scientific notation. I can move that decimal place. I would get log of 3 times 10 to the 4th. Now we've been writing it the other direction. Remember that 10 to the 4th times 3 and 3 times 10 to the 4th is the same. I actually usually do put it like this. The only reason I wrote it like this first is because that's usually how we see scientific notation. And that's the way you can think about not thinking about it as a new concept. And now I see log base 10 of 10 to the 4th is 4 plus log of 3. And the way I use my log tables is I go back, so I'm going to have 4 plus whatever log of 3 is. If I don't have a calculator, I would need a log table. So, I'm going to go back to our log table. I go to this spot, log of 3 on my calculator is 0.4771. So I'm going to add 0.4771. So my final answer is 4.4771. So again, on a problem like these, we would have to give you the log table because you wouldn't have a calculator. Let's try one more. Log of 0.1, 2, 3, 4. Okay. So if I have log of 0.000004, again, my first job is to rewrite it in scientific notation. Well, I'm going to put 10 to some power first, and it's 1, 2, 3, 4, 5, 6. So I moved it 6 to the right, so it's 10 to the negative 6 times 4. So I now know I'm going to have negative 6, because that's what this gives me, plus the log of the second number, so log of 4. My final answer would be negative 6 plus. Again, I'd have to go back to my log tables, and this time I find my log of 4, which is 0.6021. 0.6021. I add these up and I get negative 5.3979. So these two things are the types of problems we'd want to be able to take away from this lesson. And then the main focus of the lesson was understanding where this property comes from.